Hello, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, editor of Pumps and Systems Media. Welcome to Pump Technology, Helping Manage Labor Challenges, sponsored by Unibloc Hygienic Technologies. Our presenter today is Arthur Hernandez. Arthur is an expert with Unibloc Hygienic Technologies. He excels at building relationships with his processing customers and shares his expertise gained in the process engineering space for more than a decade. He has seen every type of pump used in food processing and what can go wrong. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session, and please send your questions through the Ask Question box, and we'll get to as many of them as possible. Now I'll turn it over to Arthur to begin the presentation.
Thank you, Amy. Again, welcome and thank you for joining us today. Our goal is that you're able to learn something new and walk away with a few ideas that will help you with your quality processing efforts. To preface our discussion and help manage expectations, I just wanted to let you know this is not a presentation on the subject of AI or new robotic technology to replace human labor. This industry that we work in is a very human-powered industry that depends on its workers to deliver for consumers on a daily basis. Our discussion today is a review of new and existing pump technology that depends on the labor workforce and will also help keep you safer in your daily activities. Just a little bit more about me. I've worked in the sanitary market for over 10 years with a focus on valves and pumps. I've walked hundreds of food and beverage processing plants, from small startups that can fit into small regular size homes to huge production facilities with over 100,000 square feet of production floor space. I really do have a passion for this industry, and for the last 26 months, I've been working with Unibloc Hygienic Technologies. Now, before we jump into the slide deck, I'm going to turn off my camera, and then I'll return back after we finish the slide deck and move into the Q&A. A quick introduction on Unibloc. We're a precision engineered sanitary pump manufacturer in Atlanta with global manufacturing facilities. We have a variety of pumps and processing equipment to support the various industries, from food and beverage, meat and poultry, to pharma, and even tanker trucks that offload food-grade ingredients. So let's review the main topics of our discussion today and what you can expect to learn. We'll discuss some contributing factors of worker shortages and their challenges. We'll talk about how pump designs impact your overall costs and how those designs are evolving. We'll also look at various pump features that are most effective at reducing labor. And finally, we'll run through a few scenarios that will help illustrate the savings and payback, or ROI, return on investment, that comes from investing in new pump technology. So to begin, here's a recent study from Packaging Machinery Manufacturers Institute, or PPMI. They cited that nearly 2/3 of meat processors face the challenge of a manufacturing worker shortages. According to a report by the Manufacturing Institute, manufacturers would need to fill 4 million jobs by 2030. That's more than half, either 2.1 million, that will go unfilled unless more people become interested in working in the manufacturing industry. Unfortunately, the experienced manufacturing workforce has already retired or is nearing retirement age. Now, I know that this is not earth-shattering news, but this challenge has affected all food industries across the board, which means we're all pulling from the same very depleted talent pool. Here are some reasons why recruiting has been difficult: wage growth, record high inflation, and an extremely competitive labor market have put business leaders in a difficult position. Employees' pain points and concerns for cost of living has caused employees to disengage or leave the company in search for higher salaries. And that makes it difficult to replace experienced workforce that have left or are close to leaving. Manufacturing jobs have also lost their luster, mostly because the dwindled workforce requires those employees to work longer hours, especially with the added pressure of keeping up with customer demand. The food manufacturing industry faces many obstacles when it comes to attracting workers. Arguably, the foremost reason is the unpleasant nature of the work itself. Many plants are unavoidably uncomfortable. They're difficult work environments that are commonly noisy, cold, hot, with many physical hazards ranging from falls to repetitive motion industries. Rural areas have been hit the hardest with workforce shortages due to smaller talent pool and the impact of gas prices because of the long commutes to their plants. And I've noticed working in the South Central region that there are many chicken and beef plants concentrated in these rural areas to have proximity to their suppliers and independent farmers. And still, many production plants are struggling with worker shortages. So here's a poll question. I'm going to hand it over to Amy, and we'll go through this one together.
Yeah, sounds great. So you should all be seeing a poll question on your screen. This one is, how would you rate your difficulty in finding quality maintenance/sanitation employees? We'll give everybody about 30 seconds to answer before we move on to the results. Okay, just a few more seconds. All right, let's see. Looks like overwhelmingly difficult is how they would rate things. Arthur, do you have anything to add?
No, this is absolutely in line with what we're seeing in the market, just because of some of the reasons we have already discussed, just difficulty attracting new talent, young talent to the industry. And hopefully by the end of the presentation today, there'll be some ideas and some things that you can implement to help support you in your efforts to bring new employees and even maybe new technology to your facility. So let's continue. In addition to worker shortage challenges, it takes significant time to train new workers. According to PPMI, 12% of meat processors say skill gaps are at their top of their operational concern. And to make matters more complicated, there is a high turnover causing operational crews to constantly train new employees. Training for any job, no matter what the skill level, can be a major point of worker dissatisfaction. It's a huge challenge, and especially in times of high turnover. This can strain a workforce, especially when the plant needs to crank up production to meet demand. This kind of inflexibility will drag down worker retention in the long run. There have been many times where I visit a plant, and a few months later, during a follow-up visit, I find out those individuals no longer work there. Another challenge contributing to worker shortages is the nature of the work itself. As I mentioned earlier, physical hazards and unpleasant conditions add to the dissatisfaction with the work environment, especially in the maintenance and/or sanitation processes. These jobs are mostly done during second or third shifts, or perhaps on the weekends during a plant shutdown. Although there are some monetary incentives for working these shifts, the challenges still exist as the job itself is very physical. It is also often poorly supervised and has extreme time constraints to complete the tasks. And the work environment can be very uncomfortable. Many plants outsource these sanitation processes to a third-party company, which can help alleviate the demand on a plant's local workforce. But time constraints, quality control of the work performance, and training of that sanitation crew still falls under the responsibility of the hiring plant to ensure it's done correctly. It reminds me of a sanitation company that was fined $1.5 million by the Department of Labor earlier this year for hiring children between the ages of 13 and 17 years old to work overnight and sanitize slaughterhouses in Iowa and Virginia. These labor challenges are real and have a long-lasting effect on the workforce and corporations. Now, under that same topic, let's take a quick poll question.
Yeah, great. So again, you should be seeing this on your screen. The question is, who completes your regular sanitizing process? Either internal employees or outsourced company. We'll give everybody about 30 seconds to answer. While you're answering that, I just want to remind everybody, if you have a question of your own, please send that through the Q&A box and we'll get to that after the presentation. Give it a few more seconds. All right, it looks like the majority, almost 70%, said internal employees. Arthur, do you have anything you'd like to add?
Sure, and this one is just a little surprising. I know, according to recent studies, it's about 50%, so this is a little higher than the studies. So it's good to know that the folks on this call are taking that challenge and taking that responsibility themselves. So yeah, very interesting.
Okay, great.
According to the U.S. Food and Drug Administration, estimates that there are 48 million cases of foodborne illnesses annually. That's roughly affecting 1 in 6 Americans per year. The FDA understands the importance of food safety and has guidelines with strict recommendations on how to handle the food processing equipment and tools. Sanitary equipment is designed to minimize the potential growth for disease-causing bacteria or pathogens that can contaminate our food. Pumps that are designed to be COP'd or cleaned out of place must be cleaned frequently and manually. Depending on the application or product, this process can be a wash down, or in many cases must be taken to a sanitation tub to be washed or disinfected under certain washing guidelines. As an example, tanks and vessels used for dairy applications must be emptied and cleaned every 72 hours under the PMO guideline. These manual cleaning processes take time and investment, but must be adhered to for the ultimate safety of the consumer. In addition to manual pump cleaning procedures, there are other circumstantial instances that put more demand on the labor workforce. Foreign objects or process contaminants can also cause a major disruption. These contribute to costly production or line shutdowns that allow a response team to mitigate the issues. Items like plastics, O-rings, rubber, bolts, washers, foreign objects like chicken wire. That's right. I was at a plant that had chicken wire into their pump, and it was interesting because we both were scratching our heads on how that happened. These issues will shut down your line and delay your production processes, increasing the pressure on your workforce. And in many cases, the pump itself can be damaged. Also, the pump could be a source of contamination, either due to metal parts, O-rings, delaminated diaphragms, or other parts that wear. All these contaminants and many others can cause major delays or worse, a safety recall, like we've seen several this year with companies like Bruce Pack, Boar's Head, Purdue Foods, AW Farms, and Hickory Hollow, just to name a few. These recalls are very devastating to a brand and costly to the company's bottom line. Now, some good news. There are some pump designs that help reduce and some even eliminate the possibility of foreign contaminants. These designs keep laborers in mind and help reduce the burden on the workforce. To provide you with some real-life examples, we have a video here to show you some of those pump designs. There are many pump manufacturers that can improve their design, but I only have company videos to show you the ones that we have at Unibloc. So let's start with the newly designed low pump. At first glance, you can see it has been outfitted with a swing arm, and that feature keeps the cover aligned, and it makes it very easy to swing open when removing the cover nuts. It also has a safety feature, as those rotors do not require rotor bolts. This pump model eliminates the need for tools that can often damage the pump. The second pump is an example of a traditional double diaphragm pump. To access the diaphragms for either cleaning or repair, the top and bottom manifolds must be removed by loosening a set of bolts from both manifolds. Usually what happens when removing those manifolds is the chuck balls fall out just like that, and those need to be cleaned or they can get damaged. The 8 to 12 bolts around the diaphragm still need to be removed to access the inside of the pump. Now here's an example of a newer design double diaphragm pump. It's held together by one nut, making it very easy to access the inner diaphragms. As the product runs on this design, as the product runs on the inside and the air on the outside, it makes it easier to break down. Another benefit to this design, it does not need to be removed or carted over to the maintenance shop to be worked on. You can access the diaphragms while it's still piped in your line for easy cleaning. And from what you saw in the video, it's a lot less parts to keep up with. Quick disassembly and pumps that are easier to maintain are welcome features that workers appreciate. Features like one-way disassembly and reassembly help eliminate the guesswork on how the pumps go back together. This helps to drastically reduce downtime and allows the pump to be back in service in minutes rather than hours, which equates to dollars saved. Simpler designs are more user-friendly, especially to newer or less experienced workers on the team. It also helps that multiple techs are not needed to work on these simple design pumps. They can actually split up their forces and cover more area and service more equipment versus being tied up in one area for most of their shift, working on these more difficult or traditional or older design pumps. Also, by designing tool-free assembly and disassembly features, it eliminates having multiple special tools that usually end up in someone's cart or toolbox, and then valuable time is spent trying to locate them, or ultimately the tool gets lost or tossed by accident. I was actually at a plant in Texas a few months ago where the maintenance tech said he spent over an hour looking for a tool only to find out that it had been tossed out a few months ago after a clean out. A tool-free pump design also reduces the risk of pump damage and ultimately extends the life of the pump. So I think we have another poll question, Amy.
Yeah, so this is our final poll question. It says, how often do you clean your pumps? Do you do it after every shift, daily, weekly, or other? Again, we'll give everybody about 30 seconds to answer. Just a few more seconds here. Right. So it looks like kind of a mix here. 50% said other, with the next closest answer being 22% with weekly. Arthur, would you like to add anything here?
Yet, walking different plants, there are different requirements. Some, like you said, are weekly. I think that seems to be the lion's share other than the other. The other could fall into a different category depending on the process itself, right? So this is just a good idea of the different types of requirements needed for this industry. So thank you for that. Okay, so new pumps are safer for workers. New designs are safer for workers. The larger, heavier pumps can be placed on pump bases with adjustable rolling casters so workers can easily move them out from underneath hoppers or tanks while the areas being worked on are cleaned. The adjustable feet are also used to easily line up the inlet and outlet ports of a pump to feed the system or the discharge line. A base plate also eliminates workers from having to lift heavy objects on a regular basis. Some options also provide pumps that can be outfitted with a trolley for mobility, mostly used to offload smaller batches, barrels, or totes of ingredients into their mix tanks. Not long ago, I was visiting a syrup plant, and they had a double diaphragm pump on a two-wheel trolley, and they moved it around the batch rooms to easily offload concentrates and other flavorings into the mix tanks. It was a very useful pump and versatile pump for that particular plant because they had very restricted area. Larger PD or positive displacement pumps have heavy front covers that can weigh more than 50 pounds. New pump designs offer swing arms to prevent a cover from dropping on a worker's toe or from a worker placing the cover on the floor, causing it to get damaged or contaminated. The swing arm also keeps a worker from lifting the heavy cover and potentially injuring themselves over time. Process pumps, especially in the meat and poultry environments, are designed for rigorous performance. Most of these plants are moving thousands of pounds a day of cold or near frozen product with high discharge pressures. Those moving parts constantly wear over time and must be replaced to keep the pump running properly. Some pumps have many parts and require a significant amount of time to replace seals or rebuild that pump. And if we're being honest, most workers don't want to mess with a difficult pump and usually let them run until failure. You can easily spot these types of pumps at a plant because most times they are leaking and are in very bad shape. Pumps with newer designs have fewer parts due to simpler designs. They are newly designed pumps, do not compromise the performance, but have enhanced the pump processing capabilities and longevity due to the high-grade materials and precision engineering. Due to the ease of maintenance with these new pumps, the learning curve is much quicker and service time is significantly reduced. So we talked a lot about how these new pump designs can be beneficial. There are several pump manufacturers that offer these features. But since I work at Unibloc, I can speak specifically on what we manufacture. So in this first example, we have a quick strip rotary low pump. Due to the tool-free design and front-loaded seal assembly and one-way reassembly, a worker can tear it down, clean, and reassemble this pump in 20 minutes versus 2 hours with a more traditional or older pump. In this example, that is a time savings of 1 hour and 40 minutes, which can allow the worker to complete other tasks. Here's another example. This is the Flowtronic double diaphragm pump. The simple but innovative design allows this pump to be secured with only one nut. A worker can tear it down, clean it, and return it back to service in 15 minutes without having to remove it from the line. Of course, as long as the system is locked out and tagged out. More traditional figure 8 double diaphragm pumps have mini bolts and more parts, and it usually takes about 2 hours to work on those pumps. And that includes having to take it back to the maintenance shop, tear it apart, put it back together, and bring it out to the production floor. So in this example, that is a time savings of 1 hour and 45 minutes. Imagine how much more time does that free up scarce workers to complete other tasks. Now let's go over a cost savings scenario using these examples we just went over. Let's assume a processing plant has 2 rotary low pumps. These pumps are required to be cleaned out manually. So it's a COP, or clean out of place process. Let's also assume this plant operates 6 days a week and shuts down only on Sunday for washdown. So that's 313 days of production per year. Switching over to a newly designed pump saves 100 minutes of labor times 2, because there are 2 pumps in this plant. That's a savings of 1,043 labor hours per year. Now let's take it a step further. Let's assume a worker is earning an hourly rate of $20 per hour. That's a savings of over $20,000 per year. Payback on those 2 simpler design, newer design pumps can be 2 years or sooner, depending on the initial costs. Now let's go over a second scenario. In this scenario, we're looking at a double diaphragm pump. Let's say a plant has 4 double diaphragm pumps, and these pumps are also clean out of place, and it takes them about 120 minutes to do that process. This plant is open 5 days a week, so 260 days of production per year. If they were to switch over to a new design AODD, they would save about 105 minutes of labor per day over the 4 pumps. That's 260 days per year, and that equals a savings of over $1,800 of labor hours. At $20 per hour, that's a savings of over $36,000 per year, which is almost equivalent to having a full-time employee. So in this scenario, the payback for 4 new pumps would be less than 1 year. Believe it or not, pump design has an impact on costs, and more importantly, it can contribute to cost savings. In a time when everything is going up in costs, it's important to implement new ways to save, and time saved equals dollar saved. It goes without saying that in these difficult times, departments are requested to do more with less, and the maintenance department is usually at the front lines of dealing with budget constraints. I work with maintenance teams all the time, and there is a constant pressure to keep equipment running, and fighting downtime is always the challenge. These workers understand extending the lifespan of equipment can help reduce unnecessary downtime, and unplanned maintenance is an operational disruption and ultimately a budget killer. Downtime costs tens of thousands of dollars per hour. And more than that, if your loading dock is backed up with food that is spoiling, that needs to be delivered just in time. A few months ago, I was visiting a pet food plant. And that market has exploded over the years, especially since after COVID. We've all gotten really close to our pets. And more protein manufacturers are adding these pet food lines to their production. So at this pet food plant, one of their techs had been there for over 30 years and was sharing with me the several phases of how the plant had invested into newer technology. He described that it was a challenge at first because newer equipment oftentimes just require a higher upfront cost. But he also felt the benefit and time savings that investment had on his workload. The less amount of time maintenance is working on pumps is more that they can focus on other areas like preventative maintenance, training, and compliance. These labor savings can provide flexibility to managers and help attract more workers that will ultimately alleviate the labor pressure on the team. New pump designs have fewer parts, and fewer parts mean less capital tied up in parts room and less inventory sitting on their shelf. A damaged pump can be an expensive liability. With a simple one-way assembly, it reduces the likelihood of pump damage and it's easy to return the pump back online. By totally eliminating the rotor bolts in a new pump design, you remove the need for wrenches, and most importantly, it removes the urge to use impact wrenches. Socket wrenches and impact tools are usually the culprits of over-torquing bolt heads that can push the rotor into the back of the rotor housing and force it out of tolerance. When the pump runs, it will scratch the rotor and the housing, causing it to gall and damage the pump entirely. Another issue of over-torquing the rotor bolt is it's taking the bolt head past the tolerance limit, and that will cause the bolt head to come off during the process because it's over-torqued. And just think about throwing your keys into a drawer and throwing your keys into a dryer and setting it on high. That's not a nice sound and causes major damage to your rotors and to your inside of your pump. Now, on the flip side, an under-torqued bolt can work itself loose when the pump is running and fused to the pump cover. Improper use of tools will also scratch the hardened coatings on the stainless cover and the coatings that are on the rotors and degrade the life of your pump. Using tool-free designs help extend the life of your pump. Now, as an added benefit for joining us today, we have made available to you for download 2 white papers that are helpful in the areas of pump maintenance and reliability. These white papers go into details on how to select your next pump, what to look for, and how to extend the life of your pump. I highly recommend you take a moment to download both of these white papers and become familiar with these topics. At Unibloc, we provide exceptional craftsmanship and uncompromising commitment to easy maintenance and high reliability in all that we do. With a wide variety of hygienic solutions, we take pride in working together with you to support quality food and beverage processing with our patented designs and pumps that are easy to clean and maintain. So this concludes the slide portion of our discussion, and we're open to answer some questions.
Thank you so much, Arthur, for that great presentation. In just a moment, we'll begin the Q&A session. Attendees, if you would like a certificate or of participation, I'm going to get it in a second, for today's webinar, you can do so by clicking the View Certificate button. If you have questions that you haven't sent over yet, now's the time to do so. Keep those questions coming, and we'll keep pulling them from the chat and getting them to Arthur so that we can get to as many as possible. So at that, let's begin the Q&A. The first question says, how can we assess whether our current pump systems are contributing to labor challenges, and what steps can we take to improve?
Great question. So a couple things. What it does, new pump design enhances safety. These modern pumps, they're designed with better safety features, which also reduces the risk of spills, leaks, and even hazardous exposures. The new pump designs, they reduce physical strain. And as you know, we don't want our workers to get hurt, right? So we want them to be safe. So that's another benefit for having this type of new technology. Also, on the back end, it increases efficiency. These pumps are state of the art, and they work more efficient. They reduce your downtime, and also they have materials that are safer and that give you more consistent throughput. They also give you improved reliability with better pump technology. So these facilities experience fewer breakdowns and interruptions. So reliability means that workers spend less time dealing with and having to deal with emergency repairs. So it gives them more time to be productive. And I guess ultimately that also provides a more positive work environment.
Sounds good. The next question says, what are some key metrics we should consider when calculating the payback period for investing in new pump technology? You want to look at your initial purchase costs. Traditional pumps often cost, they're less expensive up front because they don't include that advanced feature, right? So the new designs, they typically have a higher cost.
due to the advanced technology and the materials. But at the end, you gain efficiency because the newer pumps are more energy efficient, especially if you're pulling electricity and even air, right? For air-operated pumps, it requires less air on many new designs. It's important to look at what the maintenance requirements are when you're associating costs, right? We talked a little bit about time. If you're always fighting equipment, your maintenance crew or your work crew is always fighting equipment that's down, then that doesn't give them time to really focus on other things that they would really like to do: preventative maintenance, training, looking at new ways that they can do their jobs better. So these newer designs provide your maintenance crew or your technical crew more time to do what they enjoy doing and what they're brought online to do within your workforce, and not always fighting downtime. Another big piece is just look at your life cycle costs. Really looking at the lifespan. How long will this pump? What is required of this pump during that lifespan? What does it cost to repair? What are the costs of spare parts? How many spare parts do I need to keep on the shelf? Newer designs are simpler designs. Not only are they more efficient, but like I mentioned in the presentation, they require less parts in many cases. And so that also gives you an initial cost saving. And then I would say, lastly, technology and features. Traditional pumps, many lack modern features. There are new ways where plants are looking at product savings, cost of energy used, footprint, space. And so the new designs check the boxes in all those areas. And then many can offer even real-time data, so it can improve your operational efficiency.
Sounds good. We do have a couple of attendees asking about how they can access those resources that Arthur mentioned. You should, attendees, be seeing a box on your screen that has those available for you to download. So if you aren't seeing those for any reason, if you'll just let us know in that Q&A box, that you should have that available to download along with the certificate of participation. We'll move to the next question. How do the costs associated with traditional pumps compare to newer designs in terms of total ownership and maintenance?
Right. So when comparing costs with traditional designs, newer designs, there are a few factors I think that are important. Again, like I said earlier, your upfront costs, you got to weigh that out. Many folks lean, or many factories or production facilities lean towards a less expensive pump because that gives them more room for their budget to purchase other items. But at the end of the day, that traditional pump can cost you more just because of the design, perhaps the materials. The reason why that pump, the cost up front is less expensive is because of the materials they're using or the design or how it's implemented. So looking at more traditional compared to newer, yes, there is a cost up front, but in the long run, there is a tremendous savings. Our whole time together, we've been talking about maintenance, right? Maintenance requirements. Traditional pumps usually require more maintenance, which adds to the total cost of ownership. And the more that pump is down and being worked on, or even if you're cleaning your pump daily and it takes you 2 hours to clean that pump daily, where it could take you half of that time. So that gives you less downtime and more production time. That all contributes to the total cost at the end. So newer pump designs have less parts. They probably require less maintenance. They're easier to disassemble and reassemble. And also, not having so many wearable parts reduces the risk of foreign contamination. If you have more O-rings, there's just more opportunities for those O-rings to get into your process, or there's other components in the pump that can contaminate your pump or ultimately contaminate your product. And so using simpler designs, newer designs, eliminate a lot of those materials from your process, and ultimately can be contaminant free. And all that contributes to the total cost of ownership and maintenance.
Sounds good. The next question says, can you provide examples of how improved pump technology has directly impacted worker retention in processing facilities?
Sure. Yeah, great question. Well, first of all, the pump itself, how it's designed, allows the worker to easily learn new pumps. I can't tell you how many times I've been on visits at plants, and I've shown maintenance or worker crew or labor crew the new design and how simple it is. And literally you'll see a smile on their face, or they'll call their buddy or a maintenance coworker, even the manager, hey, come on in, you got to see this. Why do they get excited? They get excited because it makes their life easier, right? And it makes their life easier. They will be a happier employee because they're not having to break down these pumps all the time. Like I mentioned in one of the slides, oftentimes they run these pumps to failure because that pump is so hard to work on, or there's so many things that so many issues they've had with that pump, where that pump is even labeled as a problem child. No one wants to touch it. You want to provide technology for your workers, or the production plants should provide technology for the workers that the workers want to work on. And it's easy to learn, and it doesn't require lots and lots and lots of training to get familiar with the pump. These simpler designs are easy to work on. Again, some require no tools. And so that, I feel that gives a worker a happier work environment, especially when they're not having to move. In the larger pumps, stainless is heavy. It's a very heavy metal. And these larger pumps, when you're removing the rotors or removing the covers, it can be a strenuous work. They're probably bending over a lot, or they're having to carry those parts and put them in a basket or a tote so they can be cleaned. Over time, that just drains people out. So having new technology like a swing arm and things like that will keep your workers happy in the long run.
Sounds good. The next question is, what specific features in pump design can significantly reduce time needed for cleaning and maintenance?
So there's a couple of ways I can answer this. In the meat and poultry, that pump design is usually a COP, or clean out of place design. And so that design, again, requires that they manually clean it according to the pole. Most of it's being done weekly, some daily. And so that's that design. It requires that. If the facility has a CIP skid, they can CIP their pumps. And that's a requirement. There's certain requirements by the FDA that require those pumps to be CIP for a certain amount of time with the certain types of chemicals, and that adheres to the CIP process. So looking at the different technology, in many cases, like dairy plants and cheese plants, those pumps are required to be CIP. That's a CIP pump. It's required by the PMO, Pasteurized Milk Ordinance, for that facility, just because, milk can spoil very quickly and bacteria can grow in those products very quickly. And so depending on the type of design will really depend on what they can select. There are some facilities, and I've come across some where they have a little bit of both, right? So they have some areas where it is CIP'd, and there are some areas where they are COP'd. But for the most part, what we see in the protein protein world or meat and poultry processing, it is a COP just because of the nature of the process. A lot of things can get into the process. There are bones that can get in there. And so that requires a lot of the labor force to get in there and clean it out. But again, a simpler COP design, pump with features that make it easy for reassembly, disassembly, and making their lives a little bit easier, ultimately does help with keeping your workers happy and also, and most importantly, keeping them safe in what they do.
Sounds good. Well, everybody, that does it for the presentation today. If you have a question that you just haven't had a moment to send over, please do so. We'll still get it to Arthur and the Unibloc team so that they can answer that offline. And if for some reason we didn't get to your question, again, we'll get that to Arthur and the team to answer that offline. So that does it for today's presentation. Attendees, you can look for an email from us later today with playback to this event. And also feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars, including those from Unibloc. Thanks again to Arthur and the Unibloc team, and thank you to everyone for taking the time to join us today. Have a great afternoon.
Thank you. Appreciate it.